Hello, I'm Professor Boaz Pokroy from the Department of Material Science Engineering at the Technion. I'll be presenting shortly my research. So my research actually involves biomineralization, which is the formation of different materials by organisms in nature, and bio-inspired materials. Here you see some well-known examples: mollusk shells, bone, teeth, and so on. And the way we actually study the structure of these materials is by high-resolution characterization, such as the Titan, or we go all over the world to synchrotrons, but especially to Grenoble in France, and there we can actually study the atomic structure of these materials. And you can see it doesn't involve only science, but also fun. I'll give a few examples. The first example is the brittle star, in which we actually could show that the brittle star on its arms has a whole range of micro lenses, optical micro lenses. We have studied the structure of these micro lenses, and we showed that they have a nice mechanism, a biostrategy, to toughen these structures. Now, we of course are taking this idea from nature and also translating it to synthetic materials. So another case study which I would like to show you is that organisms can incorporate macromolecules like proteins into single crystals of chalk, which is otherwise brittle, and by this incorporation increases the fracture toughness. So we have taken this idea after we understood it, and now we can perform a whole range of materials. For example, we can incorporate synthetic proteins or polymers into the structure to enhance the mechanical properties. We can influence the optical properties of the host crystal. We can incorporate different anti-cancer drugs for drug delivery. And we can also go to semiconductors as the crystalline host and manipulate the band gap of this host crystal. Another example is that we find that in nature, single crystals often have very complex shapes and structures, and yet they are single crystals. We have taken this idea now also to gold and to other materials, and we can now grow single crystals of gold, which have, for example, different curvatures, as you can see here. Okay, so this is a single crystal of gold. We can go to another direction on the phase diagram, for example, of gold germanium, and we can form nanoporous single crystalline gold. And the third and last example is the wetting or the non-wetting of surfaces in nature of plants and of insects. As you can see here, the water thus runs off due to different structures. And we have also taken this after studying it and translated it to synthetic materials. For example, here you can see wax crystals, which are very similar to what we find in nature and leads to superhydrophobic structures and non-wetting surfaces. So this is my group, and I would be happy to discuss with you if you would like to maybe join our group for research or any other question you have. Thank you very much.